Alright, I thought I'd make a little video showcasing what I've done so far on the Rotodyne. Little history on the Rotodyne. Rotodyne was a 1950s concept. I think they only made one. It was a little peculiar. They used bleed air off the turbines and then ignite it with fuel on the tips of the rotors to get them going. So, as with most 1950s technology, it was incredibly loud and impractical. So I figured I'd improve upon it a little bit. So this is shaft drive. So there's two shafts from the turboprops going up into the rotor. When the Rotodyne was flying in cruise mode, those tip jets would shut down and it would just work like a gyrocopter. So I've kind of simulated this where over 150 knots the gear ratio is reduced on the turbine, on the the rotor, which gives more power to the turbine to go to the props, and then at over 180 knots it completely disconnects the rotor, which allows more power to go to the props even still, which gives it greater efficiency. So we'll do a quick little walk around here. As you can see, I still have microcontrollers hanging all over it. Under here we have an access port for the service hatch, so if we click the service hatch, this opens up. We have ground power, we have refueling. You can connect the ground power and you can turn on the fuel pump, which is in the nacelle here, to pump fuel into the tanks. There's about 8,000 gallons of fuel on board. There's fuselage and wing tanks. Pretty much try to mimic the Rotodyne as much as possible. You know, this is pretty accurate. These bump outs on the tail section. It has the clamshell doors. I'm going to try to make a cargo variant, and I'm going to try to make a more of a container lift variant. This one will also lift containers. As you can see, I have some hard points which connects a carriage, which will do some container lifting. This side does not have a service port on it. Over here we have our APU. So if we go under here, there's a switch on the gear door. This is a working APU in here. This is diesel, so you can fill up your diesel tank for your APU here. This is good for starting and stopping just to maintain some power. You can see still a lot of paint and whatnot to do. That's our APU. That's APU exhaust right there. And then we can close our APU door. I'll go ahead and get in. Real version had air stairs, so try to simulate that the best I can with ladder. Taking some design liberties here. This is 48 seats. As you can see, they're already set up for a Stormlink. I've been testing this in Stormlink. It works incredibly well. It's a great moneymaker for Stormlink. The paint scheme is as accurate as possible from drawings of the real aircraft. Still have some keypads in here for mostly PID tuning. Do a quick little startup. This could all change. We have moving collectives here that will move up and down with the collective of the aircraft. So we'll do master power avionics master. We'll select both batteries. We'll select both generators. We'll go ahead and we'll turn on our APU. That's going to click on and will give us power while we're going through the starting procedure. As you can see, power is going up because of the APU. So that just makes sure we're not burning down too much battery as we go into start. We'll turn on the beacon for our start. And we have our port turbine start. So once that fires off, it's going to be hard to hear just because I have the headset on the seat. Once that fires off, which it just did, we can also click the starboard turbine. They are interlinked via shaft for safety reasons and for, you know, that keeps the engines at the same RPM, as you can see. We kind of missed it because I wasn't looking outside, but there is a delay on the clutches for the props and the rotor that allows it to start more freely. You can also put it in ground idle mode, so as you can see we're at 1200 RPM. If I click on the ground idle, that will limit the RPM. It saves fuel while you're on the ground. I need to put in some stuff just to keep these needles from dancing. But alright, so we'll go ahead and we will release our parking brake. As you can see, when the parking brake is on, it shows our brake pressure is 1. That's full brake. Release it. The down arrow, as you can see, adds our brake. And, you know, we push up arrow if we want. And that's braking on the ground. We do have, I'm going to start taxiing out I'm going to use just some W off the collective for pitch. That will get us moving. You can see. So the way that I'm not sure how the real Rotodyne had yaw control. I don't think it really had much torque from the rotor because it was, used little jets or little rockets. I guess they were jets. They were just ramjets essentially off the tips. So you didn't really have any torque off of that to the body. So you probably didn't need counter torque. But since this is shaft drive, you need counter torque. So the way I've done that is the props actually they do differential pitch in the props, and that's how you get yaw control. So like right now I'm doing yaw. That's actually the one prop, the port prop going forwards, and the starboard prop is going backwards a little bit, and that, as you can see, yaws us. So we'll go ahead and put the brakes back on here. We'll go through the gauges really fast. These are all your lights up top. So I turn on the beacon. Now that we're up to power, as you can see, we have we will be gaining battery once we go into get off ground idle. Our RPM is just so low. As you can see, we are gaining battery, but that's because our APU is on. We can shut that off if we want. We'll do that in the air. Quickly going through the gauges, we have a couple of backup artificial horizons. We have skies, PFD up here on some HUDs. We have backup compass balls. This is a gear position indicator, so you have nose wheel and mains. That's showing green because they're down and locked. When they go into, you'll notice when we put them up, we'll get two yellows. This yellow is the main gear, this yellow is the nose gear, and then they'll go red when they're all the way up. And then you'll have your mains and your nose gear on up. They actually function off of the actual angle of the wheels, so you'll notice that one of the yellows stays longer than the other. That's because the nose wheel takes a little bit longer to go into the bay and stow than the mains. So we have parking brake. That's our gear selector. I need to put a limiter so it can't be down the ground. This monitor currently is showing nothing because we don't have the container carriage on there. When the container carriage is on there, it will automatically show the camera for the loading up containers. I haven't connected this yet, but this will select your video feeds and zoom on your camera. I'm going to probably change that up to the monitor. This is more container controls. You have detach the carriage, and up and down for your winch. Going through the gauges here, this is your autopilot system. Here we have port battery delta and starboard battery delta. As you can see, it's a positive number. That means we're charging the batteries, and as you can see, we are charging the batteries. If I shut the APU off, as you can see, we're actually losing a little bit because our turbines are not spun up. I'm just going to put a little bit of rudder trim in there to keep us from turning. As you see, we're losing battery because I shut the APU down, and our turbines are at low RPM, so they're not producing enough power to charge our batteries. Once we get off ground idle, that will do it. So normally you'd leave that APU on until you get in the air. So I'll actually turn it back on. You'll notice battery deltas go back to positive. We're recharging our batteries again. Underneath that, you have your generators. So if I wanted to, if I want to disconnect one of the generators from the turbine, the APU is powering it now, but that would disconnect it so that we're not recharging our batteries. This allows us to run on one battery or the other, or both. Both is recommended. So I used to be an airline pilot, so I try to set everything up, the way it would logically be done. So as you can see, this is pretty much all your battery stuff. So you have batteries, your selectors, your generators, and your deltas for your battery, essentially charge, discharge. Here we have all of our engine settings. So we have port and starboard turbine temp, which looks like something's up with that. They're showing 0. Port and starboard turbine start stops. So as long as these are on, they'll stay on. If we shut one off, they'll shut them off. We have our port and starboard turbine RPMs, and then we have master power and avionics there. Coming across, we have our fuel. So we have wing fuel, we have fuselage fuel, and we have just a total, which is adding these two together. These gauges are dancing just because we're sitting on the ground not doing much, but this is going to show us gallons per hour. Our max range in nautical miles, that's showing 0 because we're not moving, we're going very slow. We actually stopped, but and then we have fuel time in minutes. So once we're airborne and we're moving, all those will indicate correctly. Under here we have max available RPM, ground idle, rotor torque, and rotor RPM. So once we're ready to take off, we'll take off ground idle. Over here we have our autopilot, so if we click this on, that will turn on our gyro. It will also be the AP master, which allows our autopilot to work. So if we have this selected with none of these filled in, all that will do is give us the gyro. We have our altitude hold. If you enter a 0, it disables the altitude hold. If you have a 0 in the heading hold, it disables heading hold. If you enter numbers in there, it will give you the those autopilot modes. Over here we have our waypoint. So if we were to put in a waypoint from the map, all this does, we don't have a waypoint to waypoint navigation system. I like to do it manually because I actually like flying. This kind of works like an ADF, so it's going to show you the heading to the waypoint, which is 4, because I've got it set up to the Arctic, so it's almost north. If we moved our waypoint, let's move our waypoint to pretty much due east from where we are now, and we re-enter that, you'll notice that now it's showing as 086, so it's showing almost east. We have our nautical miles to that waypoint, which is 18 miles, and as you can see, it's our time is just going crazy because we're not moving. Alright, so let's get moving here. I'll do a little manual flight. So first thing we want to do is we want to take off the ground idle. As you can see, that's going to allow our turbines to spin up. You'll also notice that our battery deltas are now, we're at 100% battery. They're giving us enough power. We'll shut the APU off. So now with the APU off, we're now, this will automatically correct, but we're now making enough RPM to be able to charge our batteries. Alright, so we have the gyro on, so I'm just going to take off with a little bit of up collective, as you can see. So pretty simple, as you can see, it's simple and stable with the gyro on. Just doing up collective. I'm actually going to put in an altitude. I'll do 500 feet. And we'll let this automatically take us up to 500 feet. So as long as the autopilot master's on, you put in a number, it will select that mode. So AP master and a number and altitude hold is going to give us altitude. I still need to work on, there's a little bit of gyro instability with the roll. I just need to tune that a little bit. Alright, so we're holding about, as you can see, it's coming up on 500 now. Alright, let's put in a heading. So we're going 180, so I'll put 180 in there. And that will hold our heading. Alright, so next thing we'll do is we'll go through the gear. I'll cycle them from the inside view. We can see the gear indicator here. So if you put them up, as you can see, you notice how I was saying the yellows are different. The reason for that is the mains are faster going up than the nose wheel. So when these two greens went away, and then you get the yellow, the two greens means that the mains were unlocked and in transit, or were unlocked, and then once they disappear, and then the yellow means they're in transit, and the red means they're locked up. They're essentially in the up position. The nose wheel's slower, so as you saw, it took longer for the nose wheel to go into the yellow, and then these were already red. That was still yellow because the nose wheel was still in transit, then it went red. So we'll put them back down again. As you see, transit, the mains, and then the nose. So that's actually showing the real position of the gear. So let's, so they're down now, as you can see. And then we'll, did I left the service hatch open? I did. Okay, that's just manually me forgetting it. So let me click the gear selector, we'll watch them go up. As you can see, the mains go up faster than the nose wheel. That's why we get different colorations there. Alright, so let's go through the lights really quick. So we've cockpit lights. So we have some red cockpit lights. We have cabin lights for the rear. We have logo lights. They light up the Rotodyne. If we go into night here, as you can see, lights up the Rotodyne on the logo lights. We have taxi light, which you will not see unless the nose wheel is down. That's on the nose wheel. And if we do left-right, as you can see, we have nose wheel steering with that. We also have our landing lights. You see landing lights, and they shine through the props, which is kind of cool effect on the ground. We have strobes, which are on the wingtips. I need to put in an interrupter on those, but that will be done eventually. And this is just our nav lights, as you can see, we have greens. And then I turn the beacons on. As you see, we have flashing beacons. I turn those on when I started the engines. So, we'll get back into flight, and I'll go back to day. Just make it a little easier to see. All right, so we can. APU's done. Okay, so this is our prop pitch for our two turboprops. So we can control this with either reaching up here, or more conveniently, we can use the 1 and 2. As you can see, if I start adding 1, so I'm just going to start pushing the 1 key, and as you can see, our speed comes up. You want to go slow. See, we get a little wiggle going through 60 knots. The reason we get that is it's transitioning from the rotor controlling our our pitch roll and pitch and roll, and the props doing our yaw, to the actual control surfaces. So you'll notice it got a little bit unstable. That's just kind of a Stormworks thing. I think it has like a hard cutout for when there's enough airflow over the control surfaces to actually make them work. So you see, once we get through 160, we're nice and stable. I'll start increasing the prop even more. So with this, as you increase the prop, you'll notice the airspeed's increasing. It's now using the elevators to control our pitch, which that still needs a little bit of tuning. It oscillates a little bit, but it's not terrible. We'll keep pushing this up. I think about maybe 45 to 50% is our max speed. So that's about 200 knots, so I think it's about 50% is our max speed. Maybe not, maybe try 35. I can't recall exactly where the max speed is in this. Yeah, so it's got to be somewhere in the 45 range, I think. I keep changing things, but as you can notice, we'll do a nice 200 knots in this, which is really good for an aircraft this size. This is actually faster than the real one was. So that's our 45 is our high speed pitch for our props. If we go through these gauges over here, if you notice, we're doing 4,600 gallons per hour. That gives us a range of 330 nautical miles, and that is going to give us 100 minutes of fuel. So right now, as you can see, we're at 1,200 RPM. If I click max available RPM, it's not going to do anything because I have so much prop pitch in there that it's put enough resistance. So if I actually start slowing it down to, let's go to like 30%, we'll work around there. Now that we're at max available RPM, as you can see, we're getting more speed. So, right now we're at 30% prop pitch, max available RPM. I forgot to turn that on, that's why I'm going through it now. As you see, we get about 220 knots. The downside of this, let's see, why is my gallons per hour showing nothing? I must be using 10,000 gallons per hour because I set that up so that it will show a 0 if it's over 10,000 gallons per hour. So I need to fix that to actually show 10,000 gallons per hour, which is pretty insane. So we don't want to be burning that much fuel anyways. So let's start increasing our prop pitch. So just as in real life, as you increase prop pitch, you're going to be making the motors do more work. So they're going to be more efficient, but you're going to lose some speed. So as you see, we're doing 205 knots now, and we're going a little bit slower, but we're going to start being more efficient. So if we want max efficiency, we're going to push our props all the way to 100%. That's going to give us the max efficiency. So we're going to lose some speed, but we're going to gain a lot of efficiency, and we're going to burn a lot less fuel. So you can see we're losing some speed here. We're going down. We had a max of like 220. Now we're hanging right around 150. And as you can see, we're down to 2,000 gallons per hour. So the reason that was showing 0 is because we're over 10,000 gallons per hour. So we've lost, about 50 knots, but we've gained, a ton of fuel efficiency. So at this setting, at max prop, we're going 154 knots. We're burning 2,200 gallons per hour. That gives us 530 nautical miles of range, and that's 205 minutes of endurance. So As you can imagine, the distances in Stormworks are really pretty short. You know, I think from where we took off to here is about 45 miles. So we could do that. You know, we could go. We could do that round trip 5 times. So we go up and back to the Arctic about 5 times with max fuel and max efficiency. If we drop the efficiency down, you know, I can't. It's going to go over 10. If it goes over 10,000, it's going to zero me. So I'll have to fix that so it actually shows the max, you know, gallons per hour. But as you can see, we're, you know, right there. We're at about double the fuel burn, coming up on double the fuel burn, and we've only gained 30 knots. So it's really, if you must go somewhere fast, that's great. But you know, it's better to go full prop and save some fuel if you don't need it. So that's going to give you a lot more efficiency. Let's see what else. So let's use our navigation system really quick. We'll go to here. So I'll just put a waypoint here. So this is based off an ADF. Essentially, the way this works is the needle will tell you what heading you have to turn to get to the waypoint. So I just entered it in. I put the new waypoint in there. I'm going to look here, and it's going to say direction to waypoint 46. That's a heading of 46. So we go to heading hold and we put 46. We'll start turning towards it. I need a little tuning here on this. I need some more bank angle as well. But, a little less rudder, a little more bank angle. But that's just tweaking. And as you can see, we're heading towards it now, and it's going to roll us out. Now, the reason why it's not perfect is as we were turning, as you can see, now it's 4.2. So all we have to do is once we roll out, let's change this to 4.2. And now it's right on the money. So, you know, you can also look at this. If this number was decreasing, which it was, you could then put in an estimated guess of where you need to be. All right, so looking at that, we're heading right towards the waypoint. We're headed 4.2, 4.2. We have 11 nautical miles, and it's going to take us 4.5 minutes. So that's 4 minutes and 30 seconds to get to this waypoint. So real simple, you know, instrument navigation system. So let's go full fog. So and we'll actually take away the waypoint so that we can, so we're not cheating. So you can use this in a career mode. I've been doing a lot of Stormlink with this in career mode. You know, with this very simple navigation system, this is how planes used to navigate back in the day. You know, I don't like doing a ton of moving maps. I find it a little boring. I'd much rather have a system like this where you actually have to pilot the aircraft. So the way I put this in a lot of my creations. So the way you're going to know when you get there, one, as you can see, we have a nautical miles counting down. As we get close to the station, this needle will start to spin, and it will start to turn away from the point. We'll also, as you can see, time to waypoint is counting down. When we go past it, this will go to 0, and then it'll start counting up again as we go away from the point. This time to waypoint will go negative when we're flying away from it. So that will tell you. So you'll have a spinning needle, and you'll have a negative time when you've crossed the station. We'll actually speed up so that we can just get there a little bit more quickly, and we can finish up the video. So I'll go back down to about 30% here, get our speed up. So as you can see, that's going to give us a ton of fuel burn. So I put the limiter on 5,000. So I'll change that to 10,000. So once we hit 5,000 gallons per hour, it just zeroed it, so the number wasn't huge. So we're going about, you know, just shy of 220 knots now. As you can see, it's going to take us a lot less time now because we sped up. We're 6 nautical miles away. We're still 42, so we're still headed right to it. And we'll be at the waypoint in 1.5, so about a minute and a half. All right, so we'll watch what it does, and then we can finish up the video. All right, so 4 miles, you know, just under a minute. And if we wanted to, we can make this even more precise. We can go 43 on the heading. And that's, as you can see, we got 43 now. All right, so we're coming up on a minute to the waypoint. doing 218. Let's play with the speed a little, see if we can get more speed. So it looks like that's less speed. Let's try to go to 25, see if that gives us more speed. Nope, so it looks like 35 is our best speed. Alright, so here we go. We have 30 seconds to our waypoint. We're, you know, about a mile and 1.5 nautical miles away. Alright, so I changed the sensitivity on this needle so it might not spin as much as it normally does. But I'm trying to index it so it points right at the station, but I have to figure out the math on that. So it probably actually won't spin because I changed the settings. So, but if you notice, there we go. See, it spun on us. It went the opposite direction, and then we now have a negative number. So we passed the waypoint. So what I'm going to do is I'm going to actually turn off the fog, and if we look outside, you can see we passed right over it. So that's our navigation system. Pretty rudimentary, pretty basic. But it's very effective. It works like a real airplanes would. You know, we could add a different course if we wanted to, say, go try and do something not too close to us. Let's go right to this peninsula here. Again, we can enter that in the waypoint. We can now it's showing 340 and decreasing. So let's go 325. So we want to just get ahead of it. Especially seeing that we're this close to it, it's right here. You know, we want to put in a bigger correction. See, because we're going so fast and we're so close to it, we need more correction. So we can check it again. So let's do 290. 290. We'll check it again. 280. So let's do 270. You know, we're going to go right over it here anyways. So as you can see, it's going to go negative as we cross it, and as you can see, the needle flipped. So we get a needle flip, and we get a negative number once we cross the station. So we can use that really simple navigation system to navigate around. So every waypoint, you just enter it in and put the next one in. You know, I know a lot of people like the multiple waypoint system, which I put in my ships, because, you know, for ships you're gonna have to move around through rivers, you're gonna have to move around islands and under bridges and everything else. The distances are just so short in Stormworks that, you know, if you're going 1,000 miles, you know, you'd want to put in a bunch of waypoints, but you just don't need it for something like this. All right, thank you for watching.